Section 2.2 Polynomial Functions of Higher Degree. Our greatest weakness lies in giving up. The most certain way to succeed is always to try just one more time. Thomas Edison. So today we're going to be talking about polynomials. And these are functions whose degrees are greater than 2. So remember, if the highest exponent for x was a 2, then that was a quadratic function, which is still a polynomial. And then if it was a 1, the highest exponent was a 9, which is still a polynomial. But now we're going to look at anything greater than a degree of 3 or more. So the definition, let n be a non-negative integer. A polynomial function is a function that can be written in this form. That's the general form. And each ai, so these numbers in front of the x's, those are called coefficients and are any real numbers. And then the product, so this one and this one and this one, those are called terms. The coefficient of the variable with the highest power is called the leading coefficient. So the one with the highest power is going to be called the leading coefficient, which we'll use quite a bit. And the degree of the polynomial is the highest power of the variable that occurs in a polynomial. Polynomial functions are smooth graphs that only contain rounded curves, no sharp corners. And polynomial functions are continuous. This means that the graph has no breaks and can be drawn without lifting your pencil. So example 1, determine which of the following are polynomial functions. And so one of the important things here in the definition is that n is a non-negative integer. That's the exponent. So if we look at all the exponents here, they're integers. So this is going to be a polynomial function. G of x is equal to negative x times x squared minus 4. And so if I multiply this out, I get negative x cubed minus 4x, and I can see my exponents are non-negative integers. So this is going to be still a polynomial. And then for the third one, we have 5 square root of x plus 2. That square root of x is the same as x to the half power. So anytime you see a root, it's a fraction exponent. And so since half is not an integer, then we say this is not a polynomial. Letter D, we are given a graph. So in the definitions, it says that a polynomial is smooth with no sharp corners and that you can draw it without lifting your pencil. So this parabola is smooth, it doesn't have any sharp corners, and I can draw it without lifting my pencil. So this would be a polynomial. And here there's no sharp corners. These are smooth curves. However, in order to draw this, I would have to actually lift my pencil. When I draw this part, I would have to lift my pencil and draw this part. So that makes this not a polynomial. It's still a function, just not a polynomial. Here, I can draw it without lifting my pencil. There's no sharp corners. So this would be a polynomial. And this one, I can draw without lifting my pencil, but there's a sharp corner here. So that's not a polynomial.